Hi friends, welcome to my YouTube channel. I am Santosh Kumar. Today we are going to discuss on rated current or full load current calculations for electrical equipment like transformer DG and UPS unit. Okay, before moving into calculation of load current of electrical asset, let's derive in three-phase power 1 kVA is equal to how much amperes. So friends, we all know the three-phase power formula. So that is P is equal to root 3 VI cos phi in watts. And if we want power in kVA, so just we need to eliminate cos phi, and the power formula in volt ampere, it will come root 3 VI. So answer will be coming in volt ampere. And if you want to calculate uh, uh, amperes, then formula will become like I is equal to P divided by root 3 into V. So root 3 value is 1.732 into voltage is 415. So if we want to derive for 1 kVA, so then I is equal to 1000 divided by 1.732 into 415. So the answer is 1.3912 amperes. So now we know in three-phase power 1 kVA is equal to 1.39 amperes. So now let's calculate the rated current of different electrical equipment like DG transformers and UPS. So now let's start with transformer. So let's take one transformer rated 2000 kVA and 0.8 for power factor. Usually all electrical equipment the design and built for 0.8 power factor. And now the to calculate kilowatt, there is a formula. Power factor is equal to kilowatt by kVA. So then if we have power factor and kVA, we can able to derive kilowatt. Kilowatt is equal to kVA into power factor. So if you want kilowatt, so then kVA 2000 kVA into 0.8 power factor, so that is 1600 kilowatt. So the rated capacity of transformer is 2000 kVA and 1600 kilowatt. So now what is the rated current and full load current for this transformer? So now we know 1 kVA is equal to 1.39 amperes in three phase. So you just need to simply multiply 2000 kVA into 1.39. So the answer will be 2780 amperes. So that is 2000 kVA transformer can be loaded up to 2780 amperes, 100% full load. So but in all electrical equipment we prefer to load at maximum 80%. So this is because of three distinct reasons. One, all electrical equipment delivers highest efficiency at 80% load. That is the first reason. Second reason, all OEM recommends to use their equipment at 80% loading. And the last is the all customers, end user customers prefers to load their equipment at maximum 80%. That is because of to avoid overload, trip issues, and to have alert when it is crosses 80% without tripping. So for this purpose, usually all electrical equipment we preferred load up to 80%. So let's calculate what is the maximum ampere can be put on this 2000 kVA at the rate of 80%. So 2000 kVA transformer at the rate of 80% load is 2000 kVA into 80%, it is 1600 kVA. For 1600 kVA, if you want to convert into amperes, 1600 into 1.39. So it is coming 2224 amperes. So this transformer can load 2000 kVA transformer can load 2224 amperes till 80% of load. Okay, so just like let's calculate for DG sets. So okay, So let's take example of one DG sets 1500 kVA and 0.8 power factor. Again, we know how to calculate kilowatt. Kilowatt is equal to 1500 kVA into 0.8 power factor. So it is coming 1200 kilowatt. Now to calculate rated current or full load current, so simply we need to multiply with 1.39 amperes. So the capacity of DG set is 1500 kVA into 1.39 amp into 1.39. So it is 2085 amperes. So 1500 kVA DG set so can be loaded up to 2085 amperes for 100% load, full load. So let's derive again for 80% of loading. So 1500 kVA, 80% of 1500 kVA is 1200 kVA. So for 1200 kVA, so ampere will come 1668. So this 1500 kVA generator set can be loaded up to 1668 amperes at 80% loading factor. Yeah, now let's take one UPS unit to calculate rated current. So let's take UPS capacity 500 kVA at a power factor 0.8, and we know kilowatt is equal to 500 kVA kVA into power factor. So 500 into 0.8 is 400 kilowatt. So nowadays some of the UPS OEM, they will give you in a technical specification their UPS will work with power factor 0.9. So let's see what is the variations. Okay, if the 500 kV UPS it's working with 0.9 power factor, then kilowatt is equal to 500 kVA into 0.9 power factor, that is 450 kilowatt. So if it is 500 kVA UPS working with 0.8 power factor, you can load up to 400 kilowatt. If the same rating 500 kVA UPS working with 0.9 power factor, you can load up to 450 kilowatt. So now, what is the rated current? How do we calculate a rated current? Okay, so again, the 1 kVA is equal to 1.39 amperes. So we know, so just we need to multiply kVA with 1.39. So 500 kVA into 1.39, it is 695 amperes. Irrespective of the kilowatt consumption, whether it is 450 or 400. Okay, the rated current of 500 kVA UPS system, the full load current is 695 amperes. So that is why in rating we have not considered power factor, because it is always variable one. So that is why our all UPS transformer DGs are rated in kVA. So again, let's derive if the 500 kV UPS working at 80% load, then 80% of 500 kVA is 400 kVA. So 400 kVA in amperes, 400 into 1.39, so it is 556 amperes. So 500 kVA UPS can be loaded 556 amperes at the loading of 80%. But if you see multiple different OEMs 500 kVA UPS nameplate, okay, there's always difference in rated current or nominal current which is mentioned on nameplate. Okay, there's a difference. So if you see one of the UPS, it is showing 500 kVA UPS rated current is 720 amperes, and another UPS it's showing 500 kV UPS 670 amperes is a full load current, and one more UPS it is showing 500 kVA and 600 amperes. Why there is a change in uh, nominal current or rated capacity, rated current mentioned on different make UPS nameplates? Because there is a tolerance limit. Okay, earlier we used to discuss like what is the tolerance level of voltage. It is 430 plus or minus 10%. So the UPS voltage tolerance levels is from 380 to 480. If it is below 380, UPS will trip, and above 480, UPS will above 480 volts, UPS will trip. So that is a tolerance level. So the OEM will usually do like they will give a technical specification, different columns and different voltage ratings, and they will give nominal current. If the voltage is 380 voltage, UPS will work with 760 amperes. If the voltage level is around 400, we can load up to 720 amperes. If the voltage level is 415, 695 amperes. If the voltage level is 430, then 670 amperes. Like that, there's a different column they will give and they will update. And nowadays, in a technical specification, they will mention, they will calculate for 480 volts. Okay, like they will tell our UPS will work with 480 volt amperes and 480 volt voltage, and our rated current is 600 amperes, and this UPS can be loaded 100% load. Okay, so it is nowhere possible to give UPS input 480 voltage due to many losses due to induction loads. Okay, if you give 480 volts for UPS input, and then other equipment which is rated only for 430 or 440 voltage maximum, though those equipment will blow out. Okay, so it is practically it is not feasible to give UPS input voltage 480 volts. Okay, so that is why the different voltage calculation they will make. So that is why our kVA thumb rule, 1 kVA is equal to 1.39, so that will become false. So, so let's derive our 1 kVA thumb rule for a different voltage level. So for different voltage level, 1 kVA is equal to 1000 divided by 1.732 into 380. If the 380, if they considered, then 1 kVA is equal to 1.52 amperes. And if they consider 400, then 1 kVA is equal to 1.44. As usual, our required current, required voltage, I mean nominal voltage is 415 volts. Then it is coming 1.39. If it is 430, it is 1.34. If it is 480 volts, then it is 1.2. So after that, they will calculate what is the nominal current, and 500 kVA into at the voltage level of 380 volts, it is 1.52. 500 into 1.52, it is 760 amperes. So different column they will update. Okay, so that is why there is a little change in different OEM UPS unit. But although it is not because of the calculations is wrong, it because of they taken a different voltage level for calculation. Someone will take like input voltage as a bench, and they will put their calculation 400 amps. They will 400 volts they will take, and they will put like 500 kVA, 720 amperes is a nominal current. So if there is any difference, if you calculate 500 kVA into 1.39, the rated current should be 695, and in nameplate shows different amperes, then please check their voltage level, what voltage level they have taken. So now obviously that voltage is either they have taken other voltage other than 415, 400 volts or 430 volts. So that is why the nameplate current carrying capacity or nominal current is different than our thumb rule calculations. Thank you guys. I hope this video is more useful. Thanks for watching. Please subscribe and share for more videos. Thank you so much.